Hey, good morning, everyone. I hope I'm audible.
Yes, sir. Morning.
Morning, Dinesh, Binay, Battalion, Ravi, Muhammad Hussain. Welcome to the class, all guys. Hi, Tuan. Good morning once again. Okay, so
Oh,
hello, hi, good morning.
did you sleep?
Yeah. I sleep. Yeah,
Oh,
definitely. Yeah,
oh,
last class we
okay.
did 12-hour back, so we
Yeah.
sleep.
Yeah. Okay. Yeah.
All right. Thank you, everyone. So, welcome to the class. Let me share my screen and we can start this routing part. Okay, so as we have to complete this NRC end to end, everything we have to cover in NRC. So as we know that we have a proper syllabus for the NRC. So just quickly going through who might be missing the last class. So I'm not going to go and give the intro and all, but you just go and find this CCNP ENARSI exam topic. So I'm going to align with the proper this modules as per the NRC exam. That is the four module, layer 3 technologies. We have the VPN technologies, we have the infrastructure security and infrastructure services. So there are total four modules. Yeah, okay. So this is going to be your four module. Last week, Tuan, we just have the introduction about the syllabus, okay? Roadmap and all. So nothing is missed. We are going to start from scratch. Means I'm going to start from this first module. And in this, we're going to understand the routing protocols, right? We have the EIGRP, we have the OSPF, and we have the BGP. So I'll start with the EIGRP and we'll cover these all things, how we can do the tagging, filtering, and split horizon, route poisoning. These all things will cover this module only. So this is just considered as a first class and nothing is missed. No any technical discussion happened in the past, which you guys think that is missed for me. Okay. So there is a total four module. So we'll focus more in the advanced routing. Why this advanced routing? Because we have the NRC, that is the CCNP and Enterprise Advanced Routing, where you have to learn more about the routing. Means end-to-end BGP configuration and their troubleshootings, all scenario for the BGP, like how to build a BGP, eBGP, iBGP, their attributes, their path manipulations, how we can inject the route, how we can redistribute the route in the BGP. Like a lot of things we have in the BGP. BGP is quite big chapter. Similarly, OSPF. OSPF is going to be again very big for us because in OSPF also we have to do a lot of thing discussion. Like in OSPF we have to do configuration like different type of the network configurations. We have to define the area types, special area type like NSSA, totally NSSA, stub area, totally stub area. How we can make the ABR, area border router, ASBR, virtual link. How the cost manipulation going to happen if I need to redistribute route BGP, OSPF, and EIGRP. How it is going to be happen. Similarly for the EIGRP. So our more focus in the routing, especially for three routing protocols, EIGRP, OSPF, and BGP. And that's why you can see this module is quite big, 35%. And then we have to go and discuss about that VPN technologies, where we have to see. I'm going to give that MPLS as a full concept. It is just basic. This is going to cover in CCI. So if someone is planning for CCI, I will cover this MPLS entirely in our session. In CCNP and RC, see in CCNP and RC, we are going to be, let me show you. We are going to complete this lab, one of the biggest lab. Okay, this one. So in this biggest lab, you guys are going to get that how to make the different branches. From this different branches, how we can create the VRF And from that VRF, how we can integrate these branches. And this is going to be router, how within the core, we are going to run the MP BGP and we are going to enable the MPLS in this core, and how we are going to export route, import route between the two different PE, and we'll make the communication between the different VRF, same VRF, how we can make the LSP and all. So this is going to be bonus for everyone. Might be some small topics we'll cover in some in core and all, right? There I can, some small topic I'll just briefly cover. But MPLS I wanted to cover 100%. So you guys will become a champion. Okay. So that is the MPLS, and then more important is the DMVPN. That is also the DMVPN. So these two modules, almost 55% is the complete routing. Complete routing. Rest are the like how to secure telnet, SSH, TACACS, radius, small topics, right? That's not big. Like first of redundancy protocol, like IPv6 also going to be there. Complete IPv6. So routing is going to be not only IPv4, it's going for the IPv6 as well. So we'll have to do the IPv6 lab as well. So if you guys not having any idea how to do IPv6, so see, we have the complete IPv6 lab, and in this IPv6 lab, we are going to configure complete OSPF through the IPv6. First, we'll understand what is IPv6, what are the address schema in the IPv6, and why we need IPv6. So those theory definitely I'll cover. And then we'll configure the OSPF domain, we'll configure the BGP domain, we'll configure the EIGRP domain, and then we'll try to redistribute one routing protocol to another routing protocols. So this is all going to happen in the your IPv6 space as well. So I assume after this session, you guys will expert in the IPv6 as well. Okay. And then the last one is again for the infrastructure security like telnet, SSH, SCP, and all, like troubleshooting for the SNMP scenarios. So I'll cover these all the small topic, but the core focus in our BGP, MPLS, DMVPN, this is going to be more focus where we have to put a lot of things. These are the optionals. We'll just have to clear from the exam point of view. So I hope it's clear. If somebody is planning for the exam as well, you guys can book after this training, because this training is going to align 100% as per the Cisco curriculum. So you can book the exam. Exam fees is going to be to $300, and you can just book for any offline and online exam, and you can just give that exam as well. Okay. All right. So if you don't know about me, so myself Pankaj, and I'm instructor for the multiple technologies. So if you have any kind of the requirement for training, I train this people for CCNA, but very less now because I'm more busy in the CCNP and CCI trainings, right? And similarly, you can just learn the SD-WANs like Cisco. You can learn the Versa as well, right? From me, and the 40K SD-WAN as well. And along with that, firewalls, every leading firewall like Palo Alto, FortiGate, and Checkpoint. They are leaders in the market, so you can always reach out for any training. And at the same time, for the cloud security, Zscaler and Prisma Access, right? And also for the F5 LTM and wireless, if you have any requirements, you can just reach out. So the other training delivered by me from the GRE Technologies. So any requirement, other trainings also, we have the cloud trainings, we have the network automations, right? Like we have the data centers, right? So these are also available in any other training like Meraki and all are available. So you guys having a requirement, you can reach the GRE website. The website would be, let me tell the GRE.com, and here you can just contact WhatsApp call, and somebody is going to team from help regarding that any kind of the query for training. Total year of experience, I work in industry almost 17 years and different role. I work as a L1, L2, L3 engineer initially of the beginning of my career, and later I moved myself as a leadership role and like solution architect, network designer, security designer, and network security architect equivalent to senior manager, and work for the MNC like SCL. I work for Tech Mahindra, British Telecom, Rack Space Technologies. So big MNCs I work, and I understand how network can be designed, how network can be configured and all. So if you have any doubt for any kind of network infrastructure during the classes, don't hesitate. Please ask. Probably I will try my best to even answer the queries. Okay. All right. So before we start, anyone have any questions? Any questions, confusions, any doubt? Anything you're thinking might be you join to just ask few questions. So please ask me. Else I will start the module 1 and we'll discuss about the routing concept. We'll discuss the concept of the RIB versus FIB, and we'll also discuss about, let me put the agenda, what I'm going to cover today. So we have a lot of things. So we'll discuss about what is the routing protocol, right? Why use the routing protocols? What is the RIB, routing information base, versus FIB? That's also very important. What is the routing protocol versus routed protocol, right? We are going to understand that as well. And what else we are going to understand? And also we'll try to understand static routing versus dynamic routing. Okay, and also we are going to understand AD values, right, of routing protocol. Just introductions. So you guys at least understand from CCNA level and some brief CCNP level, and definitely why we need routing protocol, that we'll understand. And then we'll start with the EIGRP. That is going to be very first module, EIGRP. So we'll discuss this thing in first, I think 30 minutes and 40 minutes. And then after we'll start with the EIGRP because we have some short of the knowledge. Okay. So let me open my PPT. So as we discuss, right, whenever we're going to talk about the routing, what is routing? So routing is kind of the one of the method where you can take a path. By help of the routing, you can take a path to deliver any kind of the informations. Like one is source, might be this is known as a sender, right? One is going to be your destinations, that is known as a receiver. So any source want to communicate to any destinations. So how it is going to be happen? So definitely you require a path. So who is going to define the path? So path actually going to define by the routing. Okay. So routing is kind of the GPS. Let's suppose you're trying to travel from one location to another location. So you don't have any kind of the what I can say direct view how I can reach that. So you open a GPS and might be this is your unknown location and you're just going to be open a GPS. You're going to open a GPS. After opening a GPS, you're just putting a destination address. That all available path is going to available in front of you. And you're just going to see which path is going to better for me to reach one source to another destinations. So all available path is going to be there. And based on that, all available path, you're going to find only best path to reach your destination. So who is going to give that all available path information and base path informations? That GPS. So GPS is kind of your routing protocol for your means day-to-day activity when you're going to travel anywhere. Similarly, in the network space, any packet across the globe, let's suppose you are in the India and you need to travel to USA. How the packet is going to happen? In India, you must have some local ISP. Might be local ISP is going to be Jio or Airtel. So your home is connected with your office and the local ISP. This ISP further connected with any other ISP, right? Might be ISP B, it could be the Airtel. This ISP might be connected with a bigger ISP, and that is known as submarine cable, sea cable. And this sea cable further going to connect with a different ISP, and that ISP is going to make the connectivity to the US location to your home. So you have the multiple, this could be your one path. Similarly, you have the another path as well. Another path as well to go and reach to these destinations from this point of view. So might be your packet is landing to Geo. Geo might be going to use this path to reach USA. and this path to reach the USA. So this is going to be your source where the packet is going to be initiated, and this is going to be your destination where packet is going to land. Okay, so few basic misconception I found people about the routing. See, whenever you're going to do routing, I'll explain this analogy again. So routing always going to carry two field of informations. The first field of information is going to be your source IP address. Another field of information is going to be destination IP address. So let's suppose I'm in the India and my source is going to be 10.10.10.10. Destination is going to be 8.8.8.8. So when the packet is moving from this direction, these all ISP and routers are going to check destination IP address. They will never going to check the source IP address. So it will check, do I have a route to reach the destination IP? If say yes, then your packet move in the next stop. If this is the next stop, is the next stop for this particular destination route. Then again, it's going to take the destination IP address. Again, going to check the destination IP address, and then your packet reaches to destination IP address. So packet reaches to destination IP address. It doesn't mean you're going to establish the communication. No. Communication is going to only establish if this router have the routing for the source. So this is the forward packet. This is known as the forward packet. So this router must have some reverse routing. So reverse packet must be also. So whatever you have the source IP here, it is going to become a destination IP address. And whatever destination IP address here, it's going to become my source IP address. So what is my destination IP address? This destination IP address is going to be 10.10.10.10. And what is source IP address? Might be 8.8.8.8, giving the very high level example. So now if this packet want to get back to your source, again, your routing is going to start with the reverse path. And it will check, do I have a destination IP? Do I have a destination IP? Do I have a destination IP? And do I have a destination IP? And then your packet is going to reach. So keep a thumb rule. Your routing always going to happen. Your routing always going to happen based on the destination IP. Routing never happen based on the source IP address. Okay, even you are using the GPS. Why I'm giving the analogy of GPS? If you're just using the GPS, let me go here and use the map. So you'll see that, let's suppose I'm just typing the Delhi airport, and let me try to set the direction here. When you start, sorry. Okay. When you start traveling, let's suppose we are here, I am here, right? When I start traveling, I will never look back to my source. Okay. I keep travel by checking destination, whether my road is free or not, whether any traffic or not. I'll keep travel, and reach a destination. Once I reach a destination, then okay, I need to back to my home. So I'll again check my source as a destination. I'll check what path is available. So routing is also going to work in the same way. It's never work on the source IP address. Just always check the destination IP address. Yes, Siva, what is the question?
Yes, sir. When we establish a communication from the destination to source, so is it coming through the same path, or it can take the alternate path as well? Because in the destination,
depend. Yes, it's depend. It's majority of time you're going to get the same path. But let me that's a very good question. Okay, so I'll come in this particular diagram again, guys. I'll explain this communication India to USA, but similar related what Siva asked. That is a very good question. Let's suppose we are one router here. This router is connected R2 here. This is connected with the R3 here. This is connected with the R4 here. Right? This is one path. Now this is my R5. And this is going to be connect like this. Now here is my one LAN. This LAN is basically 10.10.10.10. This is my one server. This very simple example, 8.8.8.8. So now Shiva is asking, when I want to communicate from this point of view, this is my packet. The packet have two informations. The packet have two information. One is going to be your source IP address. Another is going to be your destination IP address. So what is my source IP address? Source is going to be 10.10.10. And destination IP address 8.8.8.8. Think about this router point of view. This subnet going to learn via this way as well. Destination. And this can be learned from this way as well. Now this router will install which path has a best path, because they are getting two copy of route for 8.8.8.8. But which one is going to install in the routing table? Anyone know what is the criteria to check that? How it will? Let's suppose we have the different routing protocol. Here we are using the OSPF. Giving the example, this all OSPF. This all OSPF. I just want to check your understanding. Here I'm going to use the EIGRP. So which path is going to be preferred? Anyone know that?
EIGRP.
Low AD.
Low AD, right? So we'll talk AD as well. So OSPF, generally AD is going to be 1110. And thank you, Sakil. Welcome to the class. EIGRP is going to be
Thank you, sir.
90. So EIGRP also have the multiple AD. You're going to find 170 AD. You're going to find 5 AD. There are 3 AD for the EIGRP. So lower AD is going to be there. Who not understand why lower is going to be preferred? I will talk about that. So probably this route is receiving from this EIGRP path. So whenever this router is going to send the traffic, it will choose this path. Means your packet is received from this, and it is going to be there. Okay. Now, let's suppose once you receive here, it's not mandatory always. You not have a mandatory. When it is going to reply, now packet is going to reverse. The path is going to be, might be, the destination IP is going to be your 10.10.10.10, and source is going to become your 8.8.8.8. Now, in this topology, for this router point of view, you think about that. I'm going to advertise this route into copy. There is a 10. This is IP you want to reach that. This IP you want to reach that. But I just make the two subnet 10.10.10.0/24, and I'm going to use the 10.10.10. There is another subnet I can just create 0/25. Now, what I can do that from the OSPF side, from this OSPF, I'll advertise the subnet 10.10.10.0/25 for this subnet. I advertise this 8.8/30 from both here and here both. So they have the same kind of the route receiving here. But now I'm doing the /25 advertisement from there. And from here, I'm advertising that as a /24. So this router will receive two copy of route. One, it is going to receive 10.10.0/25. And this is going to receive 10.10.0/24. So now you guys tell me which path it is going to take. It is going to take OSPF or EIGRP. Any guess?
Yes to prefix matching.
OSPF.
OSPF, right? So it is going to take OSPF. So in that case, what is happening? You sending a pack means you reaching this destination via this path, but this want to communicate, you reaching via this path. Why not AD value is going to consider? AD value is going to consider if the prefix length is going to be same. If the prefix length is going to be different, then highest prefix length is going to be always win in terms of the AD value. So this is the longest prefix length in compared to your below one. So EIGRP one. So EIGRP AD is 90, OSPF AD is 1110. But before this, we have the matching criteria that the longest prefix match. So in that case, your packet is going to reply back to different parts. So routing is depend on the multiple conditions, Siva. Okay. So it's not necessary you're going to get the always same path where you're sending the packet and the same path you're going to receive the packet. That should be ideal condition, but some cases we see in the asymmetric routing. And this is an example of the asymmetric routing, where I'm sending the traffic via the one path, but I'm receiving with a different path. Clear, Siva? It makes sense?
Yeah, that's clear, but I don't know about this OSPF and BGP stuff.
You come to know because we have to configure. I'll explain how to configure that. Then only come to know. Okay.
Okay.
Okay. Now let's
Thanks,
suppose, yeah, that's fine. Let's suppose I make the /24 only. Then what is going to happen, guys? If I just make the /24 only, then which path is it going to take? From there also /24 and here also /24. Then which path it is going to take?
EIGRP.
Yeah, CIGRP. Okay. All right. So make a thumb
Sir,
rule. Yes, please, Vinay, go ahead.
sir, let's suppose if we, we are advertising /25 through OSPF, okay, and /24 EIGRP. So, while going from R1 to R4, which path it will consider with the longest match only, right?
Yes, longest match is /25 is going to consider Vinay. That's correct.
And while returning also it will be OSPF only, not the
No. See. No. Understand. I know you a little bit confused that. No worry. See, think about, as I mentioned that routing always going to check via the destination. Now you are at this location. Clear?
Yes.
So which address you are targeting? 8.8.8. Always you have to focus on destination, never on source. You're targeting 8.8.8, right?
Mm-hmm.
This 8.8.8 learning from this path and this path. And what is prefix length? /32.
Yeah.
Okay.
Mm-hmm.
So this path also in this router, we have a 2 copy of the route. 8.8.8.8.8./32 via OSPF. Make sense?
Yes.
Another copy of route 8.8.8.8/32 via EIGRP. So if this router want to decide to go on this destination, so this path is saying you're learning the route via the OSPF, this is saying EIGRP, and both having a prefix length same. So what is the tiebreaker?
Is the AD value.
AD value. So which AD value, OSPF AD value is 1110 and EIGRP is going to be 90. So which path it is going to take?
Bottom one.
Bottom one. Your traffic is going via this path. Now you reach the destination, okay? Because you're just targeting destination only, not source. Now you have to return back to the source. So your source will become a destination. Just think about this one now. Clear?
Okay.
Now this path is sending a prefix 10.10.0/25. And this path is sending the /24. This AD is 1110. This AD is 90. So which one is going to prefer? This is 25, this is 24.
Yeah, the 25 one, the longest.
The longest prefix match is going to take precedent over your AD value. That's why when you're going to return, your OSPF is going to prefer. So always think about routing from the destination point of view. Never think about the routing about the source point of view. That make your thumb rule, guys. Everyone. This make
in this case, it will not be a asymmetric routing.
This is asymmetric routing. This is asymmetric routing. This is the asymmetric routing. Asymmetric routing will only create an issue if you have a firewall in between. If there is a firewall in between of the routing, then your traffic is not going to work. Even some scenario I have seen flat network for the routing, or might be the DMVPN, might be your VPLS circuit, where we are not using any firewall and all. So asymmetric routing is also, people deploy that due to the design consideration and all. So that your routing is working. But this is the asymmetric routing that is not recommended. always we have to recommend. I given the answer to the Siva because he asked the questions. Is it possible the return path is not going to choose the same path where it is going on? So yes, it is possible we can do that. But the best design use case is you never make a symmetric. Always you have to make a symmetric path. Okay, Bina?
Okay. Yep. Thank you.
All right. Any other question before I erase this? All right. So now moving guys, the next step I was talking about when you're going to reach from any source, let's suppose you're in the India, and by sitting in India, you want to reach in the USA, you have the multiple ISP between you. ISP A, this is going to be ISP B, right? ISP B, and this is going to be your ISP C. Okay, so there could be the multiple ISP, and that's why you are going to connect it here. This could be the one ISP group. This could be the might be the another ISP. You have the backup path as well, A, B, and C, and that is going to connect like this one as well. So always your routing is going to happen destination based address, and it will always choose best path. And who is going to help to choose the best path? That is a routing protocol. So routing protocol are going to be your friend, and they are going to help to choose the best path. And most important, involved any network communication, or I can say any internet communication. Not possible, not this one, without routing. Think about anything, just let me know anything, even you think about the AI, this will not work without routing. Data center, it will not work without routing. Any aeroplane services, air services, not work without routing. Any submarine services, like any sea services, like ships and all, any communication, it's not possible without routing. Any banking services, any other companies, everyone need an internet. Without internet, nothing is possible to make the communications. And to run the any services on the internet, we require the routing. Even you have become a firewall engineer, cyber security engineer, cloud engineer, Linux engineer, server engineer, every time you have to depend on the routing. If there is no route, you cannot build any communication. Trust me, guys. So routing is a DNA for the all network security and cyber security concept. And I strongly recommend everyone. Thank you guys for everyone for choosing this right decisions. You are learning the routing. Even you are going to configure the any firewall, guys, firewall have all routing information. And trust me, people are very confused. If I go and log in one of the firewall, let me show, because I'm the instructor for that firewall, and I just trained the brief about that how the routing going to be configured in the firewalls, the Palo Alto firewall, FortiGate firewall. But in these firewalls, let me log in the both firewall. You're going to find complete routing informations. Even BGP, OSPF, EIGRP is not supported, but you're going to find BGP, OSPF. This is a FortiGate firewall. So let me show you. So read write only. See, in the FortiGate firewall, if you go in the network, let me change the route window. If you're going in the network, under this network, okay, so we cannot have the control from here. I need to go in the FortiGate manager now. Let me see from here. It's not showing. Because it's a FortiGate manager base. So you are going to find all routing information here. Right now, it's a FortiGate manager. So let me check that IP. Okay, let me show from the FortiGate manager directly. So you guys can get, this is a FortiGate firewall managed by the FortiGate manager. So not all information available here. Okay. Yeah. I'm just showing you. See. So if I'm going to device manager, this device NC network. Let me go in the root. Yeah. So you can see we have the RIP, we have the OSPF, we have the BGP, and we have the static route. This is a 40 gate firewall. So this is also required the complete routing. So if you coming from the CCNA and CCNP ENARSI, your life is going to be easy to learn the firewalls as well and to understand how routing is going to be configured. What is the mean of the OSPF neighborship, BGP neighborship, how to get the eBGP, YBGP, what is the OSPF, normal area, stub area, totally a stub area. Similarly for the Palo Alto as well, you go in the network and if you're going in the network, you're going in the virtual router. You are going to find that all routing protocol, you have the static route, RIP, OSPF, EIGRP not supported. EIGRP earlier it was a Cisco proprietary. Now it's just open standard, but still most vendors not support these protocols. So you're going to find that RIP, OSPF, EIGRP and BGP multicast as well. So that's what I'm saying, guys. It's very important to know the routings. Routing are backbone for the any communications. Without routing, you cannot run anything across the globe, right? So end goal of the routing is a process to select the best path to reach the any destination network. What is the definition of routing? Routing is the process of selecting the best path for any packet to reach the destination. And how the best path is going to be selected? Best path selection depend on the multiple methods, right? So let me put some highlight how to select the best path. So if you're going to select the best path, this can be best path selection process for any routing. So very first thing, this is going to become as a AD value. Means if you're receiving a two route and the both having a same prefix length, the very first thing it's going to check the prefix length. Prefix length is basically your subnet marks of the prefix. So higher, let's suppose I have a two prefix. Let me put it in this way. If this is the R1, R2, the same example, R3 and R4. This R4, 4.4.4.4 /32. And again, I'm sending 4.4.4.4.4.4./30. So might be I'm going to send both are running the OSPF. Means this is a OSPF, and here we are running the let's suppose EIGRP again. Okay, EIGRP, sorry for bad writing. So if I'm sending the prefix from the EIGRP, this one, and this one is going to be /30 from the OSPF, so definitely this is going to be preferred because this having a /30 prefix length, /32 prefix length. This is /30. So longest prefix length is going to always take a precedent over your shortest prefix length. That is the very first criteria. So if I'm going to again send this /32 from this OSPF and this 30 via the EIGRP, so definitely OSPF is going to win while they are having the lower AD. But in case we have we are sending the both prefix with the OSPF and EIGRP like 4.4.4.4./32, then you're going to prefix length find as a same. Here also 32. Here also 32. So what is the tiebreaker is going to happen? Tiebreaker is going to happen the AD value. So lower AD value is going to be your EIGRP 90 and OSPF is 1110. So 90 is going to win. So this is how you do the best path selection process in the normal case of the routing. Yes, Siva?
So what's the AD value? It's a administrative distance or?
Yes, it's the administrative distance. So AD value, if I just search about that, you guys must be learned in the CCNA. Okay, the very concept. So this is known as the administrative distance. It's going to represent the numerical value by the router to determine the trustworthiness of the routing protocols, or we can say like which is going to help to find the best path, best cost, best metric based on the ID value. The path metric I will explain later on. But you can see here the router learn the multiple path to the same destinations. If router is learning this multiple path with the same destination, like is in our previous scenario, it's prefer the path with the lowest AD value. Okay, so AD value is going to between 0 to 255 value. So if you go and check what is the AD value for the different routing protocol, so let me write it here. So we have the multiple type of the routing protocol, and each routing protocols we have the different kind of the AD value. Like if I first of all I talk about the first routing protocol, then is known as the what is known as that is the connected. Anyone know the connected route? Have you guys seen the connected route?
Directly connected.
So have you guys seen the directly connected route?
Yes.
Yeah.
Okay, that's fine. And then we have the static route. Clear? Then we have the dynamic route. Under dynamic, we have the multiple route. Like we have the RIP, we have the EIGRP, we have the OSPF, we have the BGP. So basically IBGP, eBGP, and also we have the ISIS. Okay, so now you guys tell me what is the AD value of the connected route? Anyone know that?
0.
Okay, so any connected route is always have the AD value is 0. A static route,
1.
1. RIP,
120.
yeah. EIGRP,
90.
anything else?
170 and 5.
Yes, there is 3 AD values for the EIGRP. Sorry, this is the EIGRP. I just EIGRP, not EGRPR. Okay, EIGRP. It's typo. So there is a 3 AD value. I will discuss why these 3 AD values. I just for timing you guys note these values. Okay. OSPF
110.
110. IBGP
220.
200.
200. Yeah.
This is for
eBGP 20.
20. And ISIS
115.
yes, 115. Right. ISIS 115. So you can just find it here. You can see there the AD value. So you're going to find static connected route always 0. This is the static. This is going to be eBGP, EIGRP. This is not mentioned about the other values 70 and 5. I'll discuss OSPF 110, RIP 120, IBGP 200. It's not mentioned ISIS. So ISIS AD value we are not going to cover, but at least you should know this is also protocol. It's going to be 115. So you can see this ISIS is 115. So this is a complete set of the AD value, and when we're going to use routing, so if any route is coming, now let me ask one question to you all and try to help me to answer. This is a router, okay? This router is connected with the R2, this is connected with the R3, and this is connected with the R4. Here we're running the static routing protocol, static. Here we're running the OSPF, okay? OSPF. Now, if I create one of the loopback here, like on this router, I get the loopback 10.10.10.10/32. And now I'm advertising one of the subnet from here 10.10.10.10/32. From this path I'm configuring via static, and from this path also sending to the OSPF. So this router have the 3 routes. Okay. One route is going to be which protocol? Anyone know that?
Static.
Think about it. This is a loop back. This is static, this is
Connected.
here. Yes.
It's
So
connected.
this is going to be connected. Second one is going to be
Static.
Static.
static. And third one is going to be?
OSPF.
OS.
So which route this router will select to communicate? Since
Static.
connected.
Prefix length is same, so static. AD value 1.
Connected is going to be preferred. Nothing directly
Connected.
connected. So it's a
Okay,
0 AD
zero.
value, right?
Yeah.
Connected is 0. This is the 1. So this is a 120. It will never install these two routes in routing table, starting in OSPF, unless we have the connected route. So it will always give the preference for the connected route. That is my intention to ask this question. So you always have to give the route that is going to be connected with the higher preference. If this route is not there, this loopback is not connected here, then which one is going to be preferred? Static. Makes sense, na? Because we have the lower AD value. If this is
Yes,
static
sir.
not here, then it is going to be OSPF. So this is how you're going to be do the decisions. Now, we have to understand when we're going to design the routing table, because we know that it is static, connected and everything, but you are going to design the routing table, then how routing table is going to decide which route I need to install in my routing table. So they build two table. In routing table, if you go that, they build two table. One is going to build your rev, and one is going to build your fib. Rev is going to known as the
Routing information base.
yes, routing information base. Fib is going to known as the
Forwarding information base.
yes, forwarding information base. I'm putting in short name. So earlier we discussed this. We have the loopback, we have the static, and we have the connected. Does router is going to put all router means all routing information in the routing table? The technically answer is yes, but not in the exact forwarding plane label it is going to put. It will keep the all informations in their routing database, and that is known as a routing information base. So what is a rev? Rev is basically collection of all possible route. Collection of all possible route. Whatever your route want to go in destinations. In that case, I have a 3 route, 1, 2, 3. So if this router trying to build a RIP, it will keep all information. This one, and this one. But which one is going in the your routing table only? Means forwarding information base. Which route is going to install?
Connected.
Yes,
Best
only
one.
connected. Best one is going to install the routing table. So FIB is a forwarding based information. It is going to collection of the best route only. So routing table is the database containing all known routes. Means you run a command show IP route. You generally run a command show IP route. So show IP route is going to give the best route, but in background they use the rev and fib. So in rev they collect that they collect all information of the routing information base, whatever the all possible route, static, connected, they store that, and based on that rev they create the fib, means how quickly I can forward the packet. So that is the data plane routing. This is the control plane. That is a collection of route, but this is the forwarding plane. Means how my data is going to be processed based on the routing tables. So that is a fib. Yes, Siva?
Yes, once, for example, if the router lands all the routing tables and it's keep it on the RIP, and later on one of the path changed, so how the router will update that?
So it will by default, see, as I mentioned that RIB is going to be collection of that all possible route. If any, let's suppose this connected route is no longer available in the routing table. Okay. So it will immediately remove that your best route from the routing table, means FIB table, and will put the another best route as a static one. So they are
Okay.
just do the automatically it will routing protocol is going to be like this is at the OS, this router having the iOS. Okay. This iOS is a software. These are the very intelligent software. So you don't have to do anything. The software itself is doing in the background. So Cisco developed the software in such a way, any failure is going to be happen, any route is going to be unreachable, any network is going to be disconnected. So it will automatically do based on the logics. So predefined
Yeah.
logic
So
program.
my question is in the OSPF path.
Mhm.
After that path, there is a change because in the after R3 there is another router added R5, like
Mhm.
example. So in that case, the router will learn that as well, or
Yeah, that also learn definitely. If you're connecting any other routes as well here, if you're connecting any kind of the connectivity like R5 here, you're talking about like this one, right? It's sending the route also, so it is also going to learn. So depend
okay.
what
So
subnet is sending that.
okay, so that will be okay. Once it's trying to find how frequent it will be trying to update the routing table, or
I
it
will
will be
update.
only
I will update. It's a very big game. Okay. So every routing protocol, they have different behavior, Siva. Okay. So
okay.
I'll update how routing update is going to happen. We are talking about the very basic right now. Still not the routing protocols. I'm just talking about the basics. Like we are in
Okay.
the
Okay.
like basic things. So I'll update about update how long it will take a time, how sync and everything, timers and everything later on. But for timing, RIP is basically routing information base. That is your control information, all possible route, and FIB is basically forwarding information base. It is going to contain your best route informations only to just send the forwarding. And always from RIB, you're going to build a FIB. FIB is never going to build means RIB is not never going to build from the FIB. FIB is going to build from the RIB. So basically, RIB is your control plane. This is for data plane. This store all route. This store best route. They use the routing process, they use the packet forwarding process. This is going to be slower, this is going to be faster, right? And built by routing protocol, this is going to create by routing protocol by using this. And this created by the only from the RIB. Means FIB is created by RIB, not routing protocol. But RIB is created by the routing protocols. So this is the RIB and FIB. Clear till here? Any questions?
Sir, when we run show IP route, we only see FIB table, right?
Yes, FIB table.
So, is there any way like we can see the RIB as well?
Yes,
Or no?
I will show like if you show the
Okay,
OSPF
thank you.
database, right? OSPF database that is going to show your all available route tables. So that is OSPF database, EIGRP topology table, BGP tables. So that is going to show your all database of the possible routes. But routing
All
information, so that is considered as a FIB table. Okay.
all good,
But
sir. Thank you.
and if you're going to show IP route, you're going to get only the RIB table. All right. Now we understand about routing protocols. Now there is one more term. Any other question before I erase this particular handwritten notes, guys?
So
Sir,
there is
one thing.
One by one. Sai, go ahead, and then Binay, go ahead. Go ahead, Sai.
thank you, sir. And for example, if we use the command like IP show route, it is showing like a FIB table. If it is we use the command like show IP neighbors, it is showing like a RIB table. Is that the same?
No, neighbor is something different, right? In every routing, like so IP OSPF neighbor. OSPF neighbor is going to get that. So yeah, GRP neighbor. Yeah, GRP neighbor is going to tell. BGP neighbor. So all different neighbor. Neighbor is just going to tell about neighbor details.
Like directly connected
This is not
routers.
going to say about the routing table informations. Route information is not going to. It's going to say the neighbor information. If you want to check the all possible route, then you have to check the like in OSPF you have to check the database.
Topology
GRP,
table.
yeah, topology table. BGP you have to check the all possible routes. So IP BGP and all. So I will show sign. You'll understand that. Okay.
Okay. Got it.
Yes, Binay, go ahead.
Sir, I have like a contradiction because so what is the difference between show IP route and then there is one command show IP ceph. So ceph like In my
Yeah,
opinion,
safe
that
is
is
basically safe is I totally understand. See, routing table and safe, they are always going to be same entry. If you check the routing table, safe is going to be just act as a Cisco Express forwarding. That is aligned with the FIB only. Without FIB, safe is never going to build. So safe is again part of the your routing table only, right? It means it's a actual forwarding plane, and Cisco Express forwarding is going to use to just immediately forward the packet, which interface is going to be travel from one source to another destinations. But safe is actually, if I just find the relation between the FIB and safe, so relation between FIB and safe. So you are going to find, see, Cisco Express forwarding. Let me clear this one. Cisco Express forwarding is proprietary layer 3 switching technology. It's not going to be open standard. The very first thing, guys. This routing RIP I'm talking about for the all kind of the network. Either you're running for the any like any kind of the Juniper and all. So Cisco Express forwarding is a proprietary layer 3 switching technologies. The FIB forwarding information base is the one of two main component to make the safe work. So as I mentioned that if you want to work as a Cisco forwarding, FIB is always going to be dependent. So you can see the RIP feed the FIB. So the RIP feeds the FIB. The router take the traditional routing information RIP and copy simplified version to FIB. That means it is going to get collection of the best route from the RIP and install in the FIB. The FIB handle the lookups. When packet enter the router, safe use the FIB table. Okay. So to build the safe entry, which interface I need to transfer the packet, you always going to refer the FIB only. Without FIB, you cannot build your safe table. So once I'll configure our routers. So I'll explain how the safe entry is going to look like. But you can see FIB handle the lookup. When packet enter the router, safe use the FIB to instantly find the destination IP address and next hop interface. So this is going to be help to process the packet forwarding, but it is going to leverage the FIB. So both are going to work on a data plane only, right? So safe are going to just maintain your MAC table and all, but here you can see the key difference between the FIB and safe. It's going to be database table and it's a complete forwarding architecture. But how this architecture is going to build? From this FIB. This FIB is going to tell which interface you have to map in your Cisco Express forwarding. So anytime packet is going to come in router, so you immediately going to forward that packet. So this all going to be built from the FIB only. So they are, safe is always going to depend on the FIB and FIB is dependent on the RIP.
okay. So when we type command show IP route, so it will display a RIP table or FIB?
FIB table. And safe is going to be your exit interface from your traffic is going to be exit.
But for a, let's say, specific prefixes, I mean 10.10.0, let's say. So I mean, if we are learning it from EIGRP and one from the OSPF, so when we do the show IP route, it will show us from both the routes, not just one.
Okay. So it will, routing table is not going to show both of the route. If you run the, let me show you.
Show one star symbol.
No,
Which
let
was-
me, if
Yeah.
you run the show IP route, routing, I don't have any configured topology here. Okay. But it's very interesting. We'll do the lab as well. Very small lab. So, but then you have any questions? Let me show that his query. Give me 1 second, guys. I'm just wanting the, okay, let me configure this one. Okay, quickly we'll do the, anyhow we do the configuration. So let me turn on. But Aline, you have any question? You're trying to ask that?
No question at this time.
Okay, good. Okay, so let's understand the 𝗵𝗍 query, and also we'll see the labs as well. Then I'll discuss the one more thing. I wanted to cover that theoretical, then I want to configure the lab, but let's do the some lab testing. Wait, guys. Wait for a while. So I will go here. That's a good question. So this is my responsibility to make you all understanding clear and understand the truth. So let's go there. Let's go there. Let's go there. Let's go there. Okay. So let me go and we'll do small lab topology. This is going to be, host name is going to be R3. I'll go here, configure, host name is going to be R4. And this is going to be there, config T. Host name is going to be R5. And this is going to be there, config T. Host name is going to be R6. Okay, so very first thing is what I can do that I will define the IP schema. So how IP schema is going to happen? Always refer this type of the IP schema when you do the labs. So we starting the labs part while doing our general discussion. So this is 3 and 4 routers. So I will use the 34 between the subnet 34.0.0.0/24 and 3 I will assign this here and 4 assign here. For this one 35, 3 and 5. So 3 assign here and 5 assign here. For this one 56, 5 assign here, 6 assign here. For this one I'll use the 46, 4 assign here and 6 assign here. So I hope it is clear to all. It's very easy. So let me do that. So interface, the interface is going to be your Ethernet 0x0 and IP address is going to be your 34. Okay. 34.0.0.0.3.255.255.255.0. No shit. Another one is going to be 30. This is 34, not 35. 34, that's correct. Okay. And this is going to be 35. Okay, no shit. Let me go here as well. Interface, I'll assign the first IP 0x0. And IP address is going to be 34.0.0.0.4. Do ping. And I will ping this point-to-point subnet. Sorry, it should be 3, not 5. I pinged the wrong IP address. So I'll make sure my point-to-point is reachable. I'm here, I'm trying to ping here. So it should be reachable. Yeah, it's reachable. Now the next step, I will configure this one. IP address is going to be 46.0.0.0.4.255.255.255.0. No shit. I'll go in the 5 as well. Interface, this is going to be Ethernet 0x1. IP address is going to be 35. It's going to be 5. So I should be able to ping 35.3. So I can ping that as well. Yeah, that is able to reachable. And that is going to be 0x2. And in this 0x2, we are going to configure 56. 56, no shit. Okay, now last is interface 0x0. Ethernet 0x0 IP address. I will go and configure that 46.6. Ethernet 0x2. And this is going to be 56.6 no shit. Let me try to ping both address 3 and 5. So I'll go and do ping. What is address? Should be 4, not 3. My bad. So let me ping it. Yeah, it's reachable. And then another address is going to be 56.5. Okay. What I'll do, I'll create one of the loopback 6. Interface loopback 6. IP address 6.6.6. And 255, 255, 255, 255. And do right. I will configure here interface loopback 3 IP address 3.3.3 255 255. Sorry. Okay. And right now we just build the basic IP schema. Now what I can do that I will go and enable the routing protocols. So for testing point of view, what I can do, I will run OSPF. I'm just running the OSPF routing protocol. I'm sure you guys don't know how to run the OSPF, how to configure the OSPF. And here I'm going to configure the EIGRP just for the brief understanding. So we'll do the EIGRP discussion again with the very depth, but these are the brief understanding: OSPF, EIGRP, EIGRP. So how to enable that? There is two methods to enable the OSPF. One is the global base, one is the interface base. So let me enable based on the interface. Okay, I will do the quickly for this side. For OSPF, I'll enable there all. So I'll go on the configuration interface, and this interface is Ethernet 0x0. So IP OSPF 10 area 0. That's all. And I will interface loopback 3 as well. And I will configure this on roles and do right. Go here R4. I will use the interface range. Okay. And there's two interface 0 and 1. On both I will enable the OSPF. IP OSPF 10 area 0. Don't worry, I will explain these all things when we discuss the OSPF. I'm just showing some basic. Okay, so here I'll enable the EIGRP on this interface. So I'll go in the R6 directly. Interface range. What is the interface? Ethernet 0x0 and loopback 6. So Ethernet 0x0, loopback 6. IP OSPF 10 area 0. And do right. So probably you'll see that OSPF neighborship is going to build. Show IP OSPF neighbor. You can still not build. Yeah, now it's built OSPF neighborship here. Here also you should get two OSPF neighbor. Show IP OSPF neighbor. Still, it's an extra state. It is going to be shown going to full stage. So wait for a while. And here also you are going to find the OSPF neighbor. No, this router is not going to find the OSPF neighbor. We'll configure the EIGRP on this one. So no OSPF neighbor. But here you're going to find show IP OSPF neighbor. So it's still next start. Wait for a while. So now you can see. So we have the OSPF neighbor. And if I try it, once we have the OSPF neighbor, you'll start getting a route. If I just run the show IP route command, you're getting this route 6.6. Still not getting 6 route. Why? Yeah, now it start getting, and it's coming with the OA, is a OSPF. So if you're trying to ping this, it's going to be reachable. Now, the next step, I'm going to configure. Just take output of this routing table. Let me put this output for your reference. Sorry. This is the routing table we have taken for the OSPF. And here also I'll check the show IP route. This is routing table without EIGRP. Now I'll configure the EIGRP below all segments. So let me go in the R3 first, and I'll configure here router EIGRP. Let's suppose AS number 100 network. I'm going to define loop back 3.3.3.3 0.0.0.0, and another network I'll define as a 35 for the my connected subnet, and I'll give the wildcard mask. Okay, do right. Done. Go in the not R4, go in the R5 now. Config router EIGRP 100 network. You are going to give that as a 35 and 56. 0.0.0.0. And this is going to be, see, it's build the 𝗵𝗶𝗱𝗏 as well. 56 and do right. Now go in the R6 and configure that router EIGRP 100 network 6.6.6, and network we are going to be enable that is a 56 as well. Right. So see, we have the so in this R5 we have the two EIGRP neighbors. Show IP EIGRP neighbor. You are going to find this neighborship which is Ethernet 0/2 and 0/1. So both sides we have the neighborship. Now let me run the command show IP route. Earlier we have this output. You can see here. Focus on the 6. This is learning by the O. O is representing the OSPF route. Okay. And this is the routing table, right? And we have the only best route available in the routing table. Now, if you're running the again show IP route, we should get both or single. What do you guys think? Are we getting OSPF route or EIGRP route?
EIGRP.
Binay?
Yes, sir. EIGRP.
So what you saying that earlier? It should be both, right?
Yes.
So now it's clear to you. Yeah. This routing table is just collection of the FIB. Okay, it's not going to take the backup route.
So if unless we have to see like both the routes, which I mean,
you cannot see in the routing table. You have to check the EIGRP show IP. You have to run the command show IP protocol summary. You have to check what all protocols. We are running the OSPF in EIGRP. Show IP EIGRP topology table. So you'll get all available route here. You can see this is all collection of route. And if you see show IP OSPF database, this is going to be there. So,
so this is my RIB table, right?
This is a RIB table for the routing protocols. And based on this RIB table, your FIB is going to be there. And based on this FIB, okay, this is based on this FIB, you want to see the SIB, show IP SIB. This is going to say this. This is also saying that you have to go via this interface. This route must be go via this interface. So your FIB and SIB is going to be always aligned. Say, if you want to go on this 6.6, it's saying that you have to forward via this port only. And see, this is the same thing you're getting in the routing table. So safe, see, this is the same, safe and FIB are going to be always. So you are not going to get the backup route in the routing table. If this is going to be down, if this path is going to be down, then what is going to happen? Which route is going to install in the routing table? Again.
Yeah,
OSPF.
So let's test it. I'm making this link down. I make this link down, and let's check the output. It will take time. So EIGRP is down. Now you'll check it here. It's become AD value is a 1110. Earlier it was a 90. So every route AD value is going to be there. Siva, you get the AD value. So AD value is always related with any route. So this is the RIB, FIB, and your SIB table. Okay. Shall I move next? If you guys allow me.
Yes.
No
So
question, no
show IP route will always displace the best active route.
route.
right?
Yes. Yes. It's not going to give the backup routes. Only the best route. Even if you have the multiple routing source, but only it's going to be best route. If I create one of the loopback here, let's suppose both links are up. And if I create one of the loopback for 6.6 on this router, then what is going to happen? It's going to check EIGRP, OSPF, or the loopback one. If I create the loopback on this router for 6.6.6, then what is going to happen? Which one is going to prefer?
Connected one,
Connected.
loopback one.
Loopback is connected. So you'll get your connected route is good. Your even EIGRP is going to remove here. OSPF. If I create here loopback 6, IP address 6.6.6 and 255, save. If you run the show IP route, see, this your OSPF EIGRP has been removed. You are getting a route in the routing table as a connected route only. If I shut down again loopback, then what is going to happen? Which one is going to be installed again? OSPF or EIGRP? Both are on. Okay.
EIGR.
So if I shut it again, shut down, this route will remove. And let me show you. See, again, your EIGRP coming in picture. So this is how automatic is going to happen. You have all database, all kind of routing information. Based on that, they're going to take an action. This is the 𝗵𝗱𝗃 and the router. I hope you guys are always remember this thumb rule and never forget about it, because we have to use this all forwarding plane and control plane for all upcoming routing discussion. Now, the agenda of this discussion, last thing about that fundamental, there is one more concept. These are out of syllabus topic, guys, okay? These things are not part of syllabus. So still I did not start with syllabus, but these are the very fundamentals. People not aware about that. Another thing is difference between routing protocol routed protocols. You guys know what is the difference between routing protocol and versus routed protocols? Any idea? What is routing protocols? Give me example of routing protocols.
RIP, OSPF, BGP, 𝗖𝗖𝗡𝗣.
Okay, let me put it here like this.
Routed protocols IPv4, IPv6.
Okay. Even your connected is going to be part of the routing protocol, right? Connected route. Static route. Okay. They are the not routing protocol. Means connected is not routing, but it's going to part of the routing decision. So I start with connected. People ignore always, but I always repeat connected. Connected is very important. Your first check is going to happen from connected, then static, then RIP, then OSPF, then means you can just put any sequence, EIGRP, eBGP, iBGP, ISIS. Right? These are the routing protocols we use that. And what are routed protocol?
IPv4, IPv6.
IPv4, IPv6, like we have Apple Talks, like that. Apple Talks, I believe you're going to find that. So these are the routed protocols. So why you use the routing protocol? What is the role to use the routing protocols?
Select the best path from source to destination.
Yes. To find the best path from source to destination address. This is the role of the routing protocol. This routing protocol will help you to find the best route, best path from one of the source to destination. That's why you use the routing protocol. So let me to find best path. And what is routed protocol?
It's predefined.
It's predefined, but what is the role? Means you know the routing protocol to find the best part, but what is why you need the routed protocol?
I forgot the explanations. Sorry.
Okay, no problem. I'll definitely give, but I'm trying to understand from you all.
For establishing the communication?
For identification in the network. I mean, it's kind of an address.
It's the
Okay.
language to speak same language so that they can communicate. So protocols, set of rules, or
This will route your packet.
More simplified answer. This will route your packet. What does mean? Means more simple layman language example, Sakil. This will route your packet. That's correct, right? So any other example you want to give that, Sakil? That's correct. The statement. This will route your packet. This routed protocol will route your packet, and this will find your best path. Any example you want to give that?
Yeah, the packet that was created, so it will actually ride on that routed protocol to reach the destination. This will take you from one point to the other point. The routing protocol only provides you the best route, but from taking one point to the other point, that would be the routed protocol.
Very nice. I appreciate it. Thank you, Sakil. Okay, Sakil is 100% right. Okay, and why it right? I know that. We learned in past together. So there is a concept.
Sir,
Yeah.
I learned everything from you.
Yeah. Okay. Thank you
Otherwise,
so much. Yeah.
I was only a beginner.
Okay. Thank you, Sakil. I appreciate it. All right. So the routing protocols are basically to find the best path. Let's suppose, as I mentioned that in Google Map, GPS, we use that. Let's suppose I'm in the Noida. Okay, this is the Noida. Is one of the city in the India who are the not from the India. So Noida is one of the city in the India, and there is a one place, Delhi, where major airport, it's another city in the India. They're very close. So I have to travel to airport, like airport. So when I start my GPS, it will give the path. It will give, you can go via this path. Okay, it will give, you can go via this path. But this path might be going to take maybe 50 minutes. This path might be 10 minutes. So I supposed to use this path. Why I supposed to use this path? Because they have the lower latency, lower time, lower traffic and all. But who helped to give me the path detail? That is a GPS. So similarly, if I'm in the router of the Noida, I want to reach the router of the destination of the Delhi airport. So my router is going to give the path. Hey, there is a two path available. This is the path 1, this is the path 2, but this is the best path for you to reach the destination. So it will just tell me the path. But now I want to travel. Let's suppose, take another layman example, GPS example. Let's suppose I want to travel from my home to airport. GPS cannot help me to, bring there. No, it will just tell me the path. But to travel myself, I need a motorbike. I need some kind of the car. So let's suppose I need a car. So I need to sit in the car, and car will follow this route and travel from this A to B destinations. So this car is going to be your routed protocol. Right? Means who carry actual payload. I am the payload. Actually, I need to travel. So I am the payload. And for me, if I want to travel from path A to path B, so that payload is going to inside of the car, and car is going to run on the road. And who given the road direction? That is a GPS. Similar way, router will give the direction for A to B destinations from source to destinations. Whatever you have a source, whatever destination, they will give your path detail. But they will not carry your packet. So if, let's suppose this is one of the router, this is the second router, this is my third router, and this is my fourth router, and this is my, now here is one of the server. This is my server, and here is my one PC. This PC having the IP 10.10.10.10. This server having IP, let's suppose 20.20.20.20. So routing protocol will help me to say, yeah, if this is running the EIGRP, this is running the EIGRP, okay? This is running the OSPF, this is running the OSPF. So this will going to tell this path is going to be best for you. But when the packet is going to be created, means your packet is going to be created, means you want to communicate. So in your packet, you have the multiple information. We have the source IP address, we have the destination IP address, we have the source MAC, we have the destination MAC, we have the source port, we have the destination port, and some additional payload, actual data. So this is going to be your complete packet. This is known as the IP packet. So to carry this entire packet, we require the protocol, and that is why we require the IPv4 protocol. This IPv4 protocol is going to help as a transporter like car, who is going to transport your packet from this location to this location. And when he is want to return back, again, it will transport your packet to there. So if you're using the IPv4, its IPv4 is going to be a transporter. If you're going to the IPv6, your IPv6 is going to transport. This we are not going to use. So generally you're going to get IPv4 and IPv6. This is your routed protocol. Clear to everyone? Difference between routed protocol and routing protocol? I hope you have the clear explanation on that.
Yes, sir.
Okay, so I believe we are good, pretty good. Let me see in today's agenda if I'm missing anything. We'll discuss this. Okay, routing table we'll discuss about RIP and FIB we discuss about. Let me check that. Route AD value we discussed about already. Okay, all right. So now, guys, we are going to start. Not today, we'll start tomorrow, already 1.5 hours. I don't want to bore you in initial stage. So tomorrow when we start the class, we'll start with the EIGRP. So I will explain these all things in EIGRP. Okay. So this all things I discussed, routing and all, static routing, this all EIGRP, OSPF, most of these are the popular routing protocols. Static, I'm not going to cover static. I believe you guys are already know about that. What is static routing for the simple connectivity and all for CCNA level. So I'm going to talk about a dynamic routing for dynamic routing protocols. Like we have the OSPF, BGP, EIGRP, and RIP. They are discovered the routing automatically. Means let's suppose I'm going to configure any dynamic routing protocol. Let me complete this slide and then we'll conclude the sessions. So static, you have to give the all routing information hop by hop manually. But in dynamic, once you enable the OSPF here, EIGRP here, or any other RIP or BGP, they will discover routing automatically. Means it will just send the all routing update to the neighbor. That's why we are using a dynamic routing protocol. For the complex network, for the enterprise network, large network, we always recommend it for the dynamic routing. For the any small network, you can use the static routing. Static routing is going to be hop by hop routing. Means every router you have to go and tell how to reach certain destination. Again, you go to the next router. Again, you have to tell how to reach the next destinations. So that's why you can see here, if I talk about the static routing, route are manually configured by the network engineers. There is no automatic updates is going to happen. You always manual intervention is going to required when link is going to fail. It's not going to be used for the large network, detailed documentations, and its advantage for the simple implementation, predictable behavior. And if you have the small network, then you can use that. And it's going to give the enhanced security. You don't have to worry about dynamic updates or not. But when you go for the dynamic routes, learn routes updates automatically by exchanging information the routing protocols. So you don't have to give every router manually how to reach the destination. No. When you're going to define the dynamic routing protocols, it will automatically update to your neighbor whatever they have the information about the any destination prefix. So it will automatic update your routing protocol. It is going to scale well for the large and complex network. It should give the faster recovery if any failure is going to happen. And also it will reduce the administrative overhead. Means you don't have to do manual configuration and all. but they will use slightly high CPU and RAM. Definitely, that's a disadvantage, but it's okay. No problem with that. And to work on this particular routing protocol, you must have the good routing protocol behavior understanding. Then you can only work on that routing protocol. And the more popular routing protocols, we have the EIGRP, OSPF, BGP, RIP, and we are not going to cover RIP. These are not going to use, and this is part of the CCNA, but we are going to cover EIGRP, OSPF, BGP. And MPLS is going to be known as the MP-BGP. So that is also going to cover DMVPN is not routing protocol, but that is the methods. VPN method will cover that also. Okay, and you can see routing protocol versus routing protocol. We discuss about that. This is going to determine your best path to route the packet. This is carry data packets between the devices. Same example I have given that. This is the addressing, logical addressing, provide the logical address, identify the devices, operation network or SI model, and layer higher level of SI model. So example, these are the routing protocols, and these are the routed protocols, IPS, IP, IPv4, IPv6, and AppleTalk. RIP versus FIB, already we discussed about that. What is RIP, what is FIB? And to get that, you just have to run the RIP and FIB. So now we have to start with the EIGRP. So we'll discuss EIGRP tomorrow, guys. Okay. So we'll discuss EIGRP tomorrow. We'll start from EIGRP discussion tomorrow. Already we are 1.5 hours. So tomorrow we'll connect and we'll start with the EIGRP, how EIGRP is going to work, what is the key concept of the EIGRP, and how we can configure the EIGRP, different key concept of the EIGRP. All right. So I believe we are good for today, guys.
Thank you, sir.
Thank you, everyone. See you again tomorrow. If any questions, please let me know. Else we are good. Thank you, everyone. Bye-bye.